Hey everyone, welcome back to my Python programming tutorials. In today's lesson, we're going to be talking about inheritance. So we've talked about all the parts of a class except these braces. And I've told you in part 1 of the objects tutorials, I've told you to kind of ignore them and we'll come back to them. So we're going to dive into what these are and what they're used for. So the brackets over here are put there to tell Python who to inherit from. And what I mean by who is from what superclass. Now we will get into the terminology very shortly, but I just want to go ahead and clarify that these brackets are there for inheritance. The basis of inheritance is that a subclass will inherit the same properties as a superclass. And I know that sounds like a bunch of gibberish right now, but I'm going to go ahead and go over the terminology so you can kind of see how inheritance works. So the first term is superclass or parent class. They're used interchangeably. This is a class from which a subclass inherits. This can be thought of as a child-parent relationship. The parent is the superclass and the child will get some of his properties. In the real world, a lot of the times biological children have a lot of the same properties that their parents do. So for example, some people might get their mother's hair color or like their father's like eyes or something like that. So in code, we have the same principle. You have a superclass or a parent, and then if you inherit from them, that means that you will gain some of the properties that that parent class has. Moving on to subclass or child class, this is the class that will inherit from the superclass. So again, going back to that analogy between child and parent, this is kind of the child, and he will get some of the properties that the parent has. Inheritance is a pretty important concept. It saves us a lot of time. We don't have to rewrite a bunch of code, but we could still get the same things done. So within these braces, we specify who we inherit from. And maybe you don't know yet, but in Python, everything inherits from object, from just this base class. So if you put this in here, this car class will have the same behavior as if it's not there. It's just if there's nothing in these braces, Python is going to default to object. So if I type in dir car, you will see all of the variables and methods that are available with this car class. And as you can see, here are num wheels, here's honk, here's drive forward, and here is class method. And as you can see, there are a bunch of other methods over here that we have not defined, but where did they come from? Well, they came from this object right here. Python has already inherited a bunch of these properties and methods from this object class over here. This inheritance stuff is already going on even without us really knowing about it. We can go a bit further and write our own objects to inherit from. Let's say now we want it to be a little more specific, and instead of just having a car, we want it to have certain car models. So let's say we want it to have a Tesla and a Nissan, and the goal for this lesson is going to be to develop these two classes. So one way we can go about developing both these classes is we can write class Tesla, and then we would literally copy and paste this code over here and change whatever we needed to. But then the next time we would go to create the Nissan class, well, we would do the same thing. We would write class Nissan, copy the code and paste it. And already you can see the redundancies. There's a bunch of the same code and we kind of want to avoid that. And that's what we're going to use inheritance for. So the way we can create this Tesla car and not have to rewrite all of this is we can inherit from car. And if we inherit from car, that means Tesla would have these properties over here. So there you go. I'm going to save this code. I've thrown in a pass there just so we don't get an error. And now if I try create a Tesla, you could see that the Tesla is already requiring these two positional arguments, color and position. We haven't specified that anywhere within here. We did not write a constructor for Tesla. However, we have written one in car over here, and the car constructor requires two arguments, the color and the position argument. That's why we're getting this error over here. So as you can see, without rewriting code, we're already getting very similar behavior to what we had with the car. So I've properly created a Tesla over here. And if I go ahead and I say dir Tesla, now you could see all of the attributes and variables that this Tesla has. And again, you could see the drive forward, the honk, the num wheels, the XYZ, color, and this class method that we've defined. But as you can see, we haven't defined any of that stuff over here. So we've avoided rewriting all of that code by simply putting that the Tesla inherits from the car. Now this works perfectly well. If I go ahead and create a Tesla object over here, this works perfectly fine. I can still access the same variables as I could with the car. As far as it looks, everything seems okay. The problem is we'd actually need to call this init method from within Tesla because this car object might be inheriting from other classes itself. So in order to make sure that all of these inheritances will inherit properly from their parents, we would need to do something like this. We would have to define define Tesla's own constructor, which again is the init method, it would intake the same parameters as we had in the car constructor. However, for the Tesla, you could also add on extra parameters if you really wanted to. But for this example, we're not going to. We're just going to stick with color and position. And then what we want to do in the constructor is we want to call the init method of the superclass. So this super method right here will return us the superclass, and then we will be able to call the init method on it, calling this method right here, and then we will be able to pass in color and position into its constructor and initialize all the variables. Now, again, this is important because if car was inheriting from someone too, we would ensure that everyone down the chain of this Tesla is inheriting properly from their parents as well. So just don't forget to call the constructor of the superclass when you're making this child class right here. And this is all that you would need to ensure that your class works correctly. So within 3 lines of code, we have managed to replicate a whole car class, and we have avoided writing all of this stuff out. This Tesla will behave the same as this car right now. Now we can go ahead and do the same thing for the Nissan class that we said we wanted to develop. So there we go. I have written out the Nissan class, and again, it's just going to inherit from car and have the same lines of code that we've had for the Tesla. So we can actually go ahead and create a Tesla object, and we can use a Tesla as if it was a car. So it can still honk, and it can do all the things that a regular car would do. And if we create a Nissan object, we would also be able to use it the same way as we would with the car. And now you can see both of them are printing beep, even though that method is not defined within either of their classes. Again, it's being inherited from the car class. Now, the good thing about inheritance, you can actually override these methods. So let's say that a Tesla were to beep longer than the original car. Well, what we can do is we could say def honk and basically define the same exact method as we had in our parent class, except we would define it slightly differently now. So we can have a much longer beep if that's what we're saying the Tesla does. And now if I run this code, if I create that Tesla object and then a Nissan object, you could see if I honk the Nissan, we would still be printing the old beep. However, if I honk the Tesla, you could see that it is printing its own overridden beep, which is going to be the longer one. So as you can see, we have modified the behavior of just a single subclass of car, but all of the other subclasses of car have been not affected by this change that we have made just to the Tesla. So this is kind of the principle of inheritance. We simply want to put all of the common methods and kind of variables into a superclass. We want to create more specialized objects inheriting from the more generic just car class. That way we can avoid writing the same code a bunch of times. And then if we really want to, we can define our own behavior within these child classes too. So that's it for this little lesson on inheritance and the way it works in Python. Hopefully you guys have enjoyed the video. If the video has helped you out at all, please like and comment as to what it helped you out with. Like usual, if you're new to the channel, please like, comment, and subscribe. It's greatly appreciated. And yeah, catch you guys in another video.